All right, this lesson is kind of an introductory lesson to Unit 4. And Unit 4 is about applying the derivative. So we've found all kinds of derivatives, but now they're going to be attached to some kind of application. So this one is interpreting the meaning of the derivative in context, and a big part of this lesson is on the units. So one thing that I find really helpful is this first statement, that each time you find the derivative, the units of the dependent variable are divided by the independent variable. All right, so the dependent variable is basically what the function tells you. So it could be the height of a diver, or it could be the speed of a car. But that's what the dependent is. And the independent is a lot of times what we call the x value. It doesn't have to be. In these cases, it's a lot of times it's t, which is time. So anyway, let's look at this table. So we have this function h of t, and t is measured in seconds, which is the independent variable. The dependent variable, which is h, is measured in feet. So if we were going to describe the units for the first derivative, h prime of t, we would take the units of the dependent variable, which in this case is feet, and divide it by the units of the independent variable, which in this case is seconds. Right? So the h prime of t is feet per second. Right? Then if we were going to do the second derivative, which we could, we would divide by seconds again. So the second derivative is going to be feet per second per second. So how fast the speed of feet per second is changing per second. All right, so then we have a new function, r of t, and t is measured in hours, and rt is measured in ounces per hour. So the derivative of that, we would take our dependent variable, ounces per hour, and divide it by the independent, which is hours. So this should be ounces per hour per hour. All right. I think this last one might be wind chill, but we have W of V. V is measured in miles per hour, and W of V is measured in degrees Fahrenheit. So we're going to take our dependent variable, degrees Fahrenheit, and divide it by our independent variable, miles per hour. All right, so let's do some more of these. So for example 1, the temperature in degrees Celsius of the water in a pond is a differentiable function W of time. The table shows the water temperature as recorded every 3 days over a 15-day period. We're going to use the data in the table to find an approximation for W prime of 12, and we're going to indicate the units per measure, the units of measure. So we're finding an approximation of the first derivative. What we're finding is the average rate of change. So, the first derivative is the instantaneous rate of change, but we can't find that from this table. So if we're going to approximate it, we're going to find the average rate of change. All right, and there are multiple ways we can do this problem. What I did is I found the average rate of change between the 12th and the 15th day. If you wanted to, you could do 9 to 15, you can do 9 to 12, you could do 6 to 15. So 12 either needs to be one of your values or it needs to be in between your values. So like I said, there are multiple ways to figure this out, but this is just one way that I chose to approximate it. All right, so that is going to be, according to the table, 22 minus 21 over negative 3, or an approximation for it is negative 1/3. All right, and then we're going to indicate our units. So we would take the degrees Celsius and divide it by days. Or it should be per day, not per days. All right, so a student proposes the function P given by that function P of T as a model for the temperature of the water in the pond at time T, where T is measured in days and P of T is measured in degrees Celsius. So they found a model for the table, basically. We want to find P prime of 12, and using appropriate units, we're going to explain the meaning of our answer in the context of the problem. So I'm going to have you guys use the calculator on this if you want to. Sorry, I have a bunch of junk open. So if you guys have your own calculator, you can use it. Hopefully you can find at home some kind of online calculator. We could do this by hand. It's not like this one is an impossible one to do by hand, but we're just going to go ahead and practice on the calculator, because finding the derivative in the calculator is something that they allow you to just plug in if it's on the calculator portion of the test. All right, so if we want to find the derivative, we are going to off a window, click the wrong thing first, and then we are going to choose number 3. All right, and we have different things we can do. I could type in this function into y1 and then choose y1 here, or because I'm already here, I'm just going to type the function into the parentheses. Now I said d of x, so I'm definitely going to use x instead of t. If you wanted to use t, it would still work. You just need to do d of t, and then make sure you use t for your variable each time. And then we are finding p prime of 12, so x is going to equal 12. All right. And then don't forget that you need to be accurate to 3 decimal places, so we can put negative 0.054, or it's truncating, or we could do negative 0.055. Either one is 100% right. All right, and then we are going to explain what it means. So this negative 0.055 means on the 12th day, because this number is 12, the temperature of the water in the pond is, sorry, I'm having a hard time writing, is decreasing by 0.055 degrees Celsius per day. All right, so when you get a negative value for that p prime of 12, that means that whatever it's measuring is decreasing. If we got positive, then whatever you're measuring would be increasing. All right, let's look at the next one. For example 2, the birth rate of penguins on an island is modeled by the function b of t, which is that function, where b is measured in penguins per year, and t is the number of years since the penguins were introduced to the island. We're going to find b prime of 2. We're just going to use the calculator. Even though we could do this, we would use the chain rule and a rule for for finding the derivative of e to the power. Anyway, we're just going to go ahead and use the calculator, and then we're going to explain the meaning again. Alpha window 3. I'm still going to use X just because it's easier for me just to click it. Alright, and then we'll type our function in here. Like I said, if we were going to use this multiple times, I would probably put it in y1 and then put y1 here. But since I'm only using it once, I'm just going to type it in there. Alright, and we want to find this when x is 2. Okay, so we would write that b prime of 2 is that value, rounded or truncated to 3 decimal places, just to make sure it's accurate to 3. All right, and then we need to explain what it means. So this means during, I have to figure out when. So, oops, sorry, let me go. We have to figure out when, since this is b prime of 2, it's 2, is t, and that's the years since penguins were introduced to the island. So during the second year, all right, and then this whole function gives the birth rate of penguins. So we would say the birth rate of penguins. I'm spelling penguins wrong. Is, and since it's a positive value, we're going to say increasing by 67.650, and then we have to get our units right. So the original units for the function b is measured in penguins per year. And then we need to divide that by another year. So this is going to be penguins per year per year. So the rate of the penguins, the birth rate of the penguins, is increasing by 67.65 penguins per year. It's how fast the rate is increasing. So when a rate increases, you get like a double year. All right, let's look at the next one. For example 3, on a certain day at a diner, the total number of food ordered taken by time t is modeled by a twice differentiable function f for t between 0 and 8, where f is the number of orders and t is measured in hours since the diner opened. The values of f prime of t, which is the derivative of f, at selected values of t are shown in the table. So we're going to use the data in the table to approximate f double prime of 5. And then we're going to explain the meaning. Okay, so we're going to do the second derivative of f. So that's going to be the derivative of the derivative. And when we're using a table to approximate a derivative, that's when we use the average rate of change to find our approximation. So f double prime of 5 is going to be approximately And then we would just need to make sure that 5, where t is 5, is in between, or 5 is one of the endpoints of our average rate of change. So let's just go from 4 to 6. Now we could go from 2 to 6. We could go from 2 to 8. We could go from 0 to 8. There's lots of ways we can do it. So don't think this is the only way to do it. Now, your notation does need to be correct. If we are approximating the second derivative, what we have on the numerator is f prime, like the first derivative, at certain values. All right, and then we can get that from our table. So that's 173 minus 209. I don't really know why I did it in that order, but it doesn't end up mattering because we get a negative over a negative, which is positive 18. All right, and then we need to write down what that means. Okay, so that means that after I figure out when, that's going to be 5 hours. Okay, and then it's going to be the rate of change, or the rate of orders taken per hour is increasing by 18 orders per hour per hour. Because we take orders per hour and divide it by another hour. Okay, one more. For example 4, the number of gallons of water in a storage tank at time t in minutes is measured by W of t equals 25 minus t squared 4 times between 0 and 5 minutes. What is the instantaneous rate of change in the amount of water of the tank at time t equals 3 minutes? And then we want to give the correct unit of measure. So when they're asking us to find the instantaneous rate of change, they're asking us to find the derivative. So W prime of 3. All right. Now, we could do this in the calculator. I think it's faster just to do it in our head. So we could just use the power rule. That's negative 2t for W prime of t. So if we put 3 into that, that's going to be negative 6. And then we want to give the correct unit of measure. So this original function, W, gives the number of gallons of water in the tank, and time is measured in minutes. So this should be gallons per minute. So there's not a whole lot of calculus, figuring you have to do. We do have to do the average rate of change, but a lot of this is interpreting. And this is important to lead up for a whole bunch of things we have to do in this unit. So your assignment is going to be the worksheet that's attached.